Right. Hello, everybody. This is Miss Piekarski. We're going over some parent function vocabulary terms and basic parent function formats and what they look like and all that fun stuff. Okay, so you should have lots of pages of notes, and the first packet of notes should have pages that look like this, where you have the headings term, picture, description, and mathematical definition. And then you should have the terms over here, and then everything else is blank. And if you look towards the end of that packet, you should have some pages that look like this. Okay, so what I want you guys to do with this packet is on these pages, the one with all the dotted lines, you're going to cut along all the dotted lines. And I know most of you know what a dotted line is, but just in case, you're going to cut, and I need you to cut as neatly and as evenly as you can along all these dotted lines so that you're separating each strip of paper. Okay, and these are the, let's look at the headings, the pictures. Whoops, let me move that, I don't want that there. These are the pictures, the descriptions, and the mathematical definition are what you're going to have here. Okay, I'm not going to help you match these up. So hopefully you either can read the description and you know what that means, or you can go online and look up some of these terms and hopefully figure out how to match them up. Okay, so for instance, I will help you on the first one. Our first term is, dang it, this keeps moving. Our first term is increasing, and the definition, or the terms and definition that goes with that, is this one, and it just says it's a picture, a graph that's increasing. It says goes up from left to right, and then mathematical definition here. And you'll notice that the description is a little bit easier to understand. That's more of our math terminology written in English and languages that we can understand. The mathematical definition is a lot more involved and much more complicated to understand. So I gave you both the description and the mathematical definition. So hopefully you can match all those up by yourself. You will need scissors and tape. Once you match these up, go ahead and tape along the sides. You don't have to tape a whole bunch, but just tape it down. Get a couple pieces of tape and tape them down so that they won't come up. I will tell you, if you're not exactly sure what terms go where, you might want to use only a little bit of tape. All right, so the next packet, you should have all about parent functions here. And so this one, it has parent functions, and then it has all this blank space. And then you should have the graph and the table over here. Well, towards the end of this packet, you should have some graphs that look like this, okay? And basically, you're just going to match up the graphs with the function, and then as you go through this video with me, you can fill in all the rest of the stuff, okay? And again, you're going to have to cut out the graphs and just tape them down kind of there's this huge blank space. So just tape them down somewhere in that blank space. If you have to cover up some of the table or whatever, go ahead. I would tape it down like on the top, right across the top like this, so the graphs can flip up. So if you do have to cover up anything, you can flip it up and see it. Okay, so this first problem, or the first parent function, is f of x equals x, and that's just a linear function. Okay, so where it says type, I want you to write the word linear. And hopefully before you've watched this video, you watched my video on how to do the domain and range in set and interval notation. And from that video, we know that our domain and range should always, at this level, at pre-cal level, we always want it in interval notation. And for this line, all possible x values go from negative infinity all the way to positive infinity. And then for the linear equation, when is it increasing? And the increasing and decreasing, you're always starting on the left side of the graph and moving to the right. And so it's going to increase throughout its whole domain. So as we're starting over here, it's way down here at negative infinity, and the graph, as we're moving towards the right, is also moving up. So it's increasing throughout its whole domain, and the domain is from negative infinity and positive infinity. This graph is never going to be decreasing, and we do not have any asymptotes. So hopefully you guys matched up all the vocabulary terms, and you know the asymptotes are lines that your graph cannot cross. And with linear equations, we don't have any asymptotes. Okay, we also don't have any minimum or maximum points. And again, with minimum, maximum, if you don't know what that is, look at the vocabulary terms. But then let's look at the end behavior, and I'm going to uncover it and then I'll read it out loud to you. So this is math shorthand, and it just says that as x is approaching negative infinity, y is approaching negative infinity, and as x is approaching positive infinity, y is approaching positive infinity. And so for a lot of you guys, you're like, what does that mean? Because that is definitely a lot of very complicated math shorthand. So I'm going to go ahead and type it up, what it means. And as x approaches negative infinity, that's just the left side of the graph. Okay, and it says that on the left side of the graph, your y is approaching negative infinity. So your graph is going down. Goes down. Okay, so that's the left side of the graph is going down. That's what you've got here. And then for the next part, as x approaches positive infinity, we're talking about the right side. And it's approaching positive infinity. For the y is approaching positive infinity, so that just means that the right side goes up. Okay? So if it helps you, if you really don't understand what all of this math shorthand means, go ahead and write it down, and then either right above it or right below it or wherever you can fit it in, just write the left side goes down, the right side goes up. Okay? All right, and then even and odd. Even and odd is about symmetry. So even once we get to a graph that has even symmetry, I'll show you what it looks like. For right now, let's just talk about the odd symmetry. So even symmetry, odd symmetry just means that it rotates around the origin. So let's say we have a line, and I'm going to make it a red line. Okay, so I have this line. Goes from here to here, right? With odd symmetry, I can take that line and I can rotate it 180 degrees along this point of the origin, and you get the exact same picture. Okay, so if you notice, I just spun this shape around 180 degrees, and I get the exact same picture no matter which way it is. Okay, so anytime you can do that with a graph, that type of function is called an odd function. All right, all of you guys should know how to type in this formula in your calculator and get this graph, and you should also know how to pull up your table. And when we pull up our table, these are the values that we get from the table. Okay, go ahead and pause this video if you need to and fill in all the information before you move on. All right, our next problem is a quadratic equation, so x squared, and like I just said, it is a quadratic equation, and its graph looks like this. Okay, and so the domain for this, and you'll find that for a lot of our parent functions, your domain is going to be from negative infinity to positive infinity. That's going to happen a lot. Okay, so basically with this graph, as we go all the way to the left, it's going to keep on going forever, and it's going to keep on going all the way to the right. Okay, the range on this one starts at 0, so that's our lowest y value, and it goes up from 0. Okay, so it goes from 0 to positive infinity. And when is this increasing? Well, if we're moving from left to right, we're actually decreasing here. So from negative infinity to 0, and these are our x values. Hopefully you guys have picked up that when we talk about increasing and decreasing, we're talking about our x values. So we decrease from negative infinity to 0. And then once we get to 0, we have a turning point, and we're going to be increasing from that point on. Okay, so from 0 to positive infinity, we're increasing. We do not have any asymptotes for this. We do not have, whoops, I did it again. we do not have any maximum points, but in this graph we do have a minimum point, and it's right here at 0, 0 at our origin. Okay, and then for the end behavior, let me uncover that and then I'll talk about it. As x approaches negative infinity, so the left side of the graph, y is approaching positive infinity. So the left side of the graph is going up, and as x approaches positive infinity, y is approaching positive infinity. So this just says that the left side of the graph is going up and the right side of the graph is also going up. Okay, this is an example of an even function, and with even functions you can cut them. Write down the y-intercept here and fold it, and if you fold it, that the shapes match on both sides. Most of you probably already know that, but just in case there are some of you that don't, I explain what an even function is. All right, if we graph this equation and pull up our table on our calculator and fill in these values, this is what we get on our table. Go ahead and pause this and fill in all the information if you need to. Our next formula is a cubic function, and the graph for that looks like this. So find that shape and tape it down here. Your domain, again, negative infinity to positive infinity, and the range is also going to be from negative infinity to positive infinity. So it keeps on going all the way down and it goes all the way up. And when is this increasing? So as we are moving from the left to the right, we are starting way down here at negative infinity, and as we're moving to the right, we are increasing the whole way. So we're increasing over the entire domain, which is from negative infinity to positive infinity. This parent function does not decrease. We do not have asymptotes. We also don't have a minimum value or a maximum value. And the end behavior is this. The left side of the graph is going down, the right side of the graph is going up, and this function, hopefully you can figure out that this function is odd. It can rotate around the origin and you get the exact same picture. When we graph it and we pull up our table, these are the values that we get. Go ahead and fill this in and get ready for the next one. I probably should have told you at the very beginning of the video, but I forgot. You do want to have all of this information for all of these graphs because you'll need it for the semester project. All right, our last one is an exponential growth equation, and you guys have seen these graphs before. We just finished a unit on exponential growth and decay. So this graph, it looks like this. This one is an exponential growth. Our next parent function is exponential decay. So with exponential growth, we are starting at our asymptote. So this one will have an asymptote, and the asymptote is when y equals 0. We don't cross this line here. And we're going to be increasing the whole time throughout the whole domain. And notice my range goes from 0 to positive infinity, and also notice that I'm using a parentheses here because I cannot land on y equals 0. That's my asymptote. This one does not decay or decrease at all. We also don't have a minimum value or a maximum value. And this one, the end behavior is a little bit different. So on the left side of the graph, my line approaches y equals 0, or it approaches 0. On the right side of the graph, it approaches positive infinity. This is neither an even nor an odd function, and when I plug in these table values, this is what I get. Okay, so notice that here my y values never go to negative, they just keep getting smaller and smaller. Okay. Next one, exponential decay. And that graph looks like this. So it's almost, if you compare the two functions, they almost look like they're reflections of each other a little bit. So this one is decreasing, and the domain is still from negative infinity to positive infinity. The range is, for the exponential growth and decay, is going to be the same, from 0 to positive infinity. This one is not going to be increasing, but it will be decreasing throughout its entire domain. And just like your exponential growth, this one has a asymptote at y equals 0. It does not have minimum or maximum values. And the end behavior is going to be somewhat similar to our last one, except opposite sides. So this one, the left side of the graph is increasing to positive infinity, or is approaching positive infinity, and the right side is approaching 0. And again, this is neither even nor odd, and our table values are there. Okay. Most of this stuff, you should be able to graph these in the calculator and pull out the table values on your own, but because most of us don't have graphing calculators at home, I am showing you in this video. All right, absolute value function. You guys should have seen these in Algebra 1 and Algebra 2. So your absolute value looks like this, and it looks like just a giant V. Okay, and again, our domain's from negative infinity to positive infinity. The range starts at 0, and I can land on 0, and it just increases to positive infinity. With this one, let's do decreasing first, because we're initially decreasing. We're going down first from negative infinity to 0, and then once we get to 0, we have a turning point, and we're going to increase. We're going to start increasing from 0 to positive infinity. This one does not have an asymptote. It does not have a maximum point, but it does have a minimum point, and that's at 0, 0 at the vertex right here. And then here's our end behavior on the left side of the graph. My graph is increasing. It's approaching positive infinity. So it's going up, and then on the right side of the graph, it's also going up. It's approaching positive infinity. This is an even function, and here are the table values. Okay, I think. You know what? I don't think I did those. What's wrong with those? Let me look at those real quick, because those don't look right. So let me go to a graphing screen. Graphing screen. Let's do absolute value. For those of you that don't know, to pull up your absolute value graph in here, you click on this button, click on that, and then you just put absolute value of x. I believe that was the parent function. Let me do Control T to pull up the table. Yeah, I totally spaced it. So I gave you the table values of x squared, and this shouldn't be. So this should be, let me rewrite that. This should be a 3 here, and a 5 here, and a 3 and a 5. So whether it's on the negative x-axis or on the positive x-axis, all of our y values are positive. All right, hopefully you didn't already fill that out and you can do corrections. All right, let's moving on to the next one. Let's see, this is a rational function. We actually have two different types of rational parent functions. We have this one where we just have 1 over x, and you get a graph that looks like that. And we also have this one where it's also a rational parent function, and it's 1 over x squared. So if you look, the right side of the graphs of the two parent functions are the same, just the left side, whether it's squared or not, will determine whether it's down here or up top here. So when it's not squared, when it's just 1 over x, it's a rational function. The domains for this are a little bit more complicated because we have asymptotes right here when x equals 0. And so, let me see. Nope. There we go. Our asymptote, one of our asymptote is where x equals 0. The other asymptote is where y equals 0. So it's this way. So we have two different asymptotes there. And for the domain, that means that we're going to be all the way from negative infinity. Once we get to 0, we have this break here. So it goes from negative infinity to 0 and or from 0 to positive infinity. And we're going to have the same range for that as well. We are going to be decreasing. Hold on. So most of you, if you look at it, it looks like you're decreasing and then increasing, but if you look carefully, you're really never increasing. You're only going to be decreasing throughout the whole thing. Now, yes, I know that I did not include the 0 here. And yes, I know we have an asymptote there, but we're going to be decreasing the whole time. So what happens is we start here on the left side, and as we move to the right, we're decreasing, we're going down. And then a lot of people say, yeah, but we jump back up. Well, kind of, but not really. Asymptotes like throw all the math rules out the window, okay? So you can't land on them, and it's just kind of weird. In the graph, it just jumps up there, and then it's decreasing again, okay? So we're going to be decreasing the whole time. We won't have any minimums or maximums, and then the end behavior is going to look a little bit weird for this one. So on the left side of the graph, way over here, now we're not talking about the center. When we talk about end behavior, we're talking about the left end and the right end of the graph. So on the very left end of the graph, we're going to get closer and closer to 0 when y equals 0. And on the very right end of the graph, we're also approaching y equals 0. This function, believe it or not, is an odd function. You can spin this graph around and you get the exact same picture. See? Well, if I could spin it 180 degrees correctly. There you go. Exact same picture, whether it's upside down or right side up. Okay? And then when you pull up your graph or your table, you get these terms. And I'm trying to remember if I changed anything on the table values on the x's. For some of my functions, I have changed the x values. All right, moving on to the next ones. Now we have our 1 over x squared. We're going to have the same domain, but range is just going to be positive, so from 0 to positive infinity. And notice we have parentheses and not brackets. This one is increasing on the left side, so from negative infinity up to 0, it's increasing. And then once we get to 0, we're going to start decreasing, so from 0 to positive infinity. We still have the same asymptotes. We still do not have any minimum or maximum values. And then the end behavior is still also going to be the same. Again, we're not looking at the center of the graph, just the ends, the left end and the right end. And this type of function is even and not odd. And then here's your table values. Notice that all of my y values are positive. Okay. Moving on, I think we just have a couple more graphs. I'm hoping to get through them before my bell rings. So now we have log base 2 of x. That's a logarithmic function. You should be very familiar with these. And this is what the graph looks like. Your domain goes from 0 to positive infinity. The range goes from negative to positive infinity. It is going to be increasing over the entire domain. Let me see, why did I put, you know what, that should be a 0. Okay, sorry, that should be a 0 right there. It's increasing from 0 to positive infinity because it's undefined when it's a negative power. And then it's never going to decrease, and the asymptote is at x equals 0. So this point here, whoops, let me do that this way. Okay, this line here is your asymptote, so it's not going to cross the y-axis, and that value is x equals 0. And then again, with like most of the parent functions, you don't end up with minimum and maximum points. And the end behavior, we're not going all the way to x is negative infinity because x in the negative side is undefined. So it's just as x approaches 0, y is approaching negative infinity, so it's going down. And as x approaches positive infinity, my y value is going up. So the right side's going up, and when I get as I get closer to 0, I get closer to negative infinity, or I go down farther. This is neither negative or even or odd. It's neither, has no symmetry at all. And then let's look at the square root function, and I think we have like this one and one more. So we have the square root function, and that one, the graph looks like this. And the domain is from positive 0 to, it's from 0 to positive infinity. My range is also the same. I don't know why I have two commas there. It's a typo. Sorry about that. I am going to be increasing over the entire domain, so from 0 to positive infinity. I'm never going to be decreasing. I do not have any asymptotes. I don't have any minimum or maximum values, and then the end behavior is as x approaches 0, so when it gets closer to 0, my graph is also getting closer to 0, so it approaches the origin, and then on the right side it's increasing or it's going up. This does not have any symmetry, and those are your terms, and you'll see that I changed some of the x values, so do me a favor and change those x values on your table so that you can have these for the y values. Also notice that when I have negative x, I have undefined for my y value. All right, last graph. This is a cubic function. The graph looks like this. All right, it's not cubic, it's cube root. And here's the domain, the range. It's going to be increasing over the entire domain, never decreasing. I don't have any asymptotes. I don't have any minimum or maximum values. And as x approaches negative infinity, so the left side of the graph is going down, the right side of the graph is going up. This is an odd function, and these are the table values that I want you to write in your notes. Okay? Hopefully you got this all written down. Pause it if you need to, rewind it if you need to, and I will see you in class tomorrow. Bye.